us continue with our next technique, which is a classification technique. This name of this classification technique is naive Bayes, and it is a classifier. So just to recap, ML has regression and classification, two types of techniques. Regression is when we are predicting continuous output, and classification is when we are predicting the finite outcomes. In that way, naive Bayes is the classifier, whereas k nearest neighbor can perform both regression as well as classification. The concept of naive Bayes is simple. I will just speak about it. Suppose we have a data. Now this data is having features x1 and x2, and there is a prediction to be performed, which is y. So on the basis of x1 and x2, we need to perform prediction y. Let us assume that x1 is binary and x2 is binary, and the prediction y is also binary. These assumptions I have taken to simplify the calculation. In reality, x and y both can be x1 and x2 can be numeric, they can be continuous, they can be binary, categorical, ordinal. Y also can be categorical, binary. So for simplifying the calculations and giving you a easy picture, we have assumed that for this example the x and y will be binary. What naive Bayes says, that calculate the probability that we get y equal to 1 when x1 is 0, and calculate the probability of y equal to 1 when x1 y equal to 0 when x1 is 0. Then calculate the probability, this is when x1 is 1, calculate the probability that y we get as 1, and when x1 is 1, calculate the probability that we get y as 0. Then calculate the probability for x2. So what is the probability that we get y as 1 given x2 is 1, and what is the probability that we get y as 1 given x2 is y as 0 given x2 is 1. So this means that this actually in practice this will be the logarithmic addition, logarithm of the ratio, and if this ratio is great, if this sum is greater than 0, then we can say that the prediction will be positive, that is y will be 1, and if this sum is less than 0, then we can say that y will be negative. So that is how the naive Bayes works. It is working on the probability and principles of probability, and we will see in the next videos how this example will be expanded and why we consider these probabilities. Thank you and keep watching. Hello and welcome back. So let us see in detail how naive Bayes works. As I said, it is a classifier, and let us say that we are trying to explore whether the classifier will work well for text classification. In text classification, we will perform sentiment analysis. Let us say that we have a corpus of text, and in that there are some sentences like I am happy and I am sad and so on. So this is the corpus of text, and we want to classify each text as positive or negative. So X will be the text, and then we have Y, which is either positive. So the first sentence is positive, the second sentence is negative. From this corpus of text, we use this as the training data, and then I have got this sentence, I am happy because I am learning, and I would like to classify this sentence or predict this sentence as either positive or negative. So once I have trained my technique, how I will predict whether this sentence is positive. So in text analysis, each word can be a feature. Of course, each alphabet also can be a feature, but let us say that each word is a feature. We calculate the probability that that word occurs in a positive sentence. For example, what is the probability that I occurs in a positive sentence? So that probability is 0.05. Probability that I occurs in a negative sentence is 0.05. So there is a equal probability that I occurs in positive as well as in negative. Because I is a general word, it can occur in any sentence. So the probability is same, that it occurs in positive and negative. When we take the log of this, we get 0, because log of 1 is 0. This probability will be cancelled and we get log of 1, which is 0. That means the word I has 0 impact on the sentiment. We continue this process and keep on adding the log of the ratio of probabilities. So the next word is am. Am also has a same chance that it occurs in positive and negative. Then happy. Happy is more likely to be positive. That is why it is 0.09 versus 0.01. Chance that happy occurs in negative sentence is very low. Now when I add this, okay, I get 0 plus 0, because log of 1 will be 0. But here we have a higher numerator and lower denominator. That means this log is going to be greater than 1. So you can see that when I sum the logs, I get a value 2.2, which is greater than 0. That means my sentence is positive. I did not check because I am learning. Ideally I should check all. I will get a sum like this. Then the log likelihood, which I call this sum as log likelihood, will be 3.3, and that sentence will then be classified as a positive sentence, because its log likelihood is greater than 0. If log likelihood is equal to 0, then it will be neutral, and log likelihood is less than 0, then it will be negative sentence. So in that way, find out the probability that each feature occurs in a positive sentence, find out the probability that each feature occurs in a negative sentence, divide that, and then calculate the log likelihood, compare it with 0, and that is your decision. Hello and welcome back. So we were talking about log likelihood, and log likelihood is we need to know what is the probability that the words are occurring in a positive and a negative sentence. So that probability, how do we get? So that is the obtained from the training data or the corpus of text, which we call as training data or training data corpus. Let us say we have this data. I am happy because I am learning NLP. I am happy, not sad, and these two sentences. So two are positive, two are negative. Because this is the training data, that means it is labeled. So that is why I can say that these are positive and negative tweets. Now these are the words that are occurring. This is the number of times the word occurs in positive sentence and negative sentence. So you can see that I occurs 3 times in positive, 3 times in negative, because I am, because these are all neutral words. Sad, not, and happy. So these are words that decide whether the sentence is positive or negative. Because happy occurs more in positive and sad occurs more in negative. So once we have counted this, then we can get the probability. So the probability is simply the number of times the word occurs in positive divided by the total number of positive occurrences of all the words. That gives the probability, and with this we have calculated the entire probability of getting in positive as well as negative for all the words, which makes it simple for us to calculate the log likelihood for a sentence. So for one example of sentence, I am happy today, I am learning. So we have I, which has equal probability, am equal, but happy is having a larger probability of being positive, and words like this lead to the log likelihood getting bigger than 1. Whereas if I take a word like this, I am sad, so the log likelihood, if you can see, I, which is, so it will be, like this, probability of positive containing I, whereas probability of negative containing I, plus probability of am positive upon am negative, and then I will write on this side we have probability of sad positive upon probability of sad negative. Okay, so these 3 we will add when I calculate this. So after this I am coming to this step. The log for sad, which I will get from here, I think this is wrong because this should be more in the negative. So this should be like this. This negative is at the denominator, positive as at the, whereas for the others it is same, and for the word am also it is more or less same. So this will be 0, this will be 0, and this will be negative, which means that the sentence will be classified as a negative sentence because the word sad occurs in that sentence. This is how the naive Bayes calculates the probabilities and then calculates the log likelihood, on basis of which it is able to give us the probability of or classify the sentence. So there are many technical details which we will not cover. We will cover the basics.